Hi everyone. Today we are going to discuss about the most important chapter from 11th class, that is Newton laws of motion. This chapter is very important for Neet and JE. So this chapter will contribute Neet questions 3 to 4 approximately and JE 1 to 2. Okay, so we'll discuss the important concepts and weightage of the concepts in order wise we'll see now. Newton laws of motion. So this Newton laws of motion will discuss the important weightage wise concepts. So first important weightage is friction. So what is meant by friction? What is different types of friction and how the angle of repose, how the motion of the blocks are connected in a horizontal and vertical and inclined. So it's all concepts will comes under friction. So this friction will contribute a 47 percentage. This is the last 10 to 15 years, previous years NEET and JE related concepts. Okay, then second more weightage chapters, that is Newton laws of motion. Newton laws of motion means what is Newton first law, Newton second law, Newton third law, how significant, what are the significance from that we'll get questions. This is the weightage is 20 percentage. The next third one is circular motion. Circular motion. So this will get a 16 percentage weightage. Then a fourth one is conservation of momentum. Conservation of momentum and impulse. So this weightage will be approximately 12 percentage. Then fifth one, equilibrium of particle. Equilibrium of particle. So this is the weightage is nearly 5%. This is the most important concepts which will cover the Newton laws of motion. Okay, so if it is a NEET exam, we can expect minimum 3 to 4 questions. And if it is a JE, we can expect minimum 1 to 2 questions. Okay, so this is the topics we have to focus more. Okay, so from Newton laws of motion. Okay, so today we'll discuss one important concept of simple mechanics in physics. Okay, the simple mechanics we'll discuss now. So the simple mechanics means let us consider one Atwood machine we have. In this Atwood machine are fully related. How we can draw the free body diagram, how they ask the problems, we'll see now. Okay, so first we have to know what is meant by FBD. That is a free body diagram. What is meant by FBD? Okay, so what is meant by FBD? Free body diagram is it is used to show the relative magnitude and direction of all forces. It is used to show the relative magnitude, and directions and directions of all forces. So that is a free body diagram. So it can be used to represent how many forces are acting on a particular system and what is their magnitude and direction. So that is our free body diagram. And in order to solve this free body diagram, we have steps. So that steps we have to follow. So first step is we have to decide the system, and all parts of the system should move with the same acceleration. So system should move with same acceleration. So we have to decide one system, that system has to move with the same acceleration. Then second point, we have to list out, various forces. So what are the different types of forces? The contact force, a frictional force, tensional force, gravitational force. So that we have to list out the various forces which are acting on a system. And here internal forces, we will not contribute that internal forces. Then third step we have to follow, we have to consider the system as a point. Okay, we'll consider the system or block as a point, and we have to represent in a vector form because direction also will matter. Then fourth one, choose the axis. We have to choose axis like x-axis and y-axis, and we have to write the equation of motion. So this is the free body diagram. Okay, so based on this, we have the problems in mechanics. Okay, so what is the meaning of this one means? Let us consider here, we placed one block. Okay, one block, or else let us consider a duster we placed on a table. Okay, let us assume this is our table. In this table, we placed our duster. So how to draw the free body diagram? And what is a free body diagram? It is used to show the relative magnitude and direction of all forces. Now, in this duster placed on a table, what are the forces are acting? First, this is here. We have the frictional force. Let us consider the duster will move this direction. Then this is our applied force, and this will exert some normal force, that is N, and same way gravitational force Fg. So representing of this all forces, we called free body diagram. And steps means, so here we have the block, that block we will consider as a system, and we'll consider as a point mass or point offset. Okay, that point offset. Then forces, normal and Fg. That is for axis along. Here, choose the axis means this will take for J cap. And here, that frictional force and applied force, that will take up as a I cap direction. Here minus I cap, here minus J cap. That one only, this 4 steps. Any system in mechanics, we have to go through these 4 points. Okay, this is the primary points to follow to solve any problem in mechanics, especially related to this friction related blocks, outward missions, these concepts. Okay, clear? That is a free body diagram. That is the steps. Now we will take one simple free body diagram of upward mission. Okay, that is a basic upward mission we'll take. So what is a basic upward mission means? Yeah, this will take. Let us take first one is basic upward mission. That is, here we'll consider one pulley. Okay, so this is our support. In this support, we'll consider one pulley here. This is our pulley. So in this pulley, attached two masses. This mass is M1, and here we have another mass, that is small mass M2. Okay, this is our assumption. Our assumption is M1 is greater than M2. So two masses we have, M1 and M2. And this is our pulley. Now we need to find what is the acceleration of the system and what is the tension of the system. Two we need to find. So for that, what we'll take according to what we discussed just now, the steps. free body diagram for block M1 and M2 we have to draw. Okay, first we'll take M1. So M1 is greater than M2 means acceleration will be downward and here acceleration will be upward. So here tensional force will be there. Here also tensional force will be there. So tension force, tensional force. So tensional force means whenever we apply some external force on the object, it will produce an opposite force. That is the tensional force means here. So here mg external force or gravitational force will be downward. So tensional force will be upward. Means that rope and string anything if we consider tensional force will be there in a upward direction. That is also force which is equivalent to F. Okay, tensional force. So this is the tensional force. And if you take for mass M1 separator and draw the free body diagram, mass M1, so downward will act gravitational force M1G, so M1G and tensional force T. Now we need to find first step. What is the net force on M1 mass? Net force on M1 mass. How to write? F net is equal to, here it is coming downward acceleration. So yeah, gravitational force will be more. So M1G minus T. Net force is what? From Newton laws of motion, M into A. So it is M1A is equal to M1G minus T. Then, so T will come to this side means T is equal to M1G minus M1A. Then T is equal to M1 take common G minus A. Let us take equation 1. Okay, so next we'll take for mass M2. So for mass M2. For mass M2, if we draw free body diagram, M2G gravitational force here will act and same the tensional force, then net force. So F net force is equal to, so here acceleration will be upward, so tensional force will be more. So tensional force minus M2G. Then F net is again it is M2A is equal to T minus M2G. Then here tension T is equal to M2 if we take common A plus G. Let us take this is equation 2. And if we observe equation 1 and 2, tension and tension both are equal. If we equate equation 1 and 2, then M1G minus M1A is equal to M2A plus M2G. So let us find acceleration. So M1G minus M2G is equal to M2A plus M1A. So here we'll take G common. G take common M1 minus M2 is equal to M1 plus M2 into A. Then A is equal to M1 minus M2 by M1 plus M2 into G. So that is our acceleration formula. Okay. So we can remember this one. If you remember this one, within less than 1 minute, we can able to solve the any problem related to this upward mission. Okay, now we have the acceleration. We need to find the tension. So how to find tension? This one, just A we have, this A will substitute here. Okay, so we'll get our tension. We'll find now. Yeah, we'll see that one. So now acceleration we have A is equal to m1 minus m2 by m1 plus m2 into g. Okay. Now we need to find the tension. So we know from equation 1 that is m1a is equal to m1g minus t. So we need to find tension means T is equal to M1G minus M1A. Then M1 if we take common, G minus A. Then M1 G minus A is this one. G minus A. A is what? M1 minus M2 by M1 plus M2 into G. So again G take outside. So M1G if we take outside it is 1 minus M1 minus M2 by M1 plus M2. Now we'll take LCM. M1G tension T is equal to M1G. So 1 minus this one. So M1 plus M2 minus M1 minus minus plus M2 by M1 plus M2. So minus M1 will get cancelled. Then T is equal to M1G M2 M2. So 2M2 by M1 plus M2. Okay. So this is our tension. Finally, our tension T is equal to 2m1 m2 by m1 plus m2 into g. That is our tension. This is our acceleration. So these two phenomena we can solve easily problems. Okay. So now we'll see the previous year questions in Neet exam related to this Atwood missions. So how they ask. Now if we see previous year question, 2020 question, 2020 question, how they asked, we'll solve with this acceleration less than 1 minute. Okay, so this is our 2020 question. So what is the question means here? We have two bodies of masses 4 kg and 6 kg are tied at the ends of the massless string. The string passes over pulley which is frictionless. Okay. And the acceleration of the system in terms of g. Now they ask you to find what is the acceleration. So while reading any physics question, you have to follow the steps. First, read the question carefully and what we have to find, that also we have to analyze it. Okay, so here they gave two bodies. Let us take M1 and M2. Here this is M1 and this is M2. We'll take and tied at the ends of a massless string. So this is our ends of massless string pulley. Then they asked for acceleration due to gravity. We know that just now we discussed the acceleration formula is what? A is equal to M1 minus M2 by M1 plus M2 into Z. Okay, just to substitute our m1 value, m2 value, we'll get A is equal to m1 is 6 minus 4 by 6 plus 4 into G. That is 2 by 10 into G. That is G by 5. 2 1 ja 2 5 ja. So our answer will be G by 5. Easily we can solve less than 1 minute. Okay, or else a shortcut trick if we want to know means m1 minus m2, which is bigger, from that we can subtract numerator. Denominator is we can add this two, m1 and m2. Okay, this is the direct formula. If you know the formula, easily we can solve. If you don't know formula, just we have to remember the trick larger minus smaller and sum of two masses. Okay, otherwise this if you don't know means again we have to get this is m1g tensional force and again m2g tensional force, so we have to solve the previous related. Okay, so easy one, easily we can get this one. Okay, so this is a one question. And if you observe the another question also, this is the another question. You see the another question. Now this is they asked with 2000. two masses are as shown in the figure are suspended from massless pulley acceleration of the system when the mass is left free. Okay, so same here also. Let us take this is m1, this is m2. And we know acceleration is what? Larger minus small. So 10 minus 5. Then sum of 2, 10 plus 5 into g. So that is 5 by 15 into g. 5 1 ja 5 3 ja. So g by 3. So that is our answer. G by 3 is our answer. Okay, easily we can get. Or else formula is what? A is equal to m1 minus m2 by m1 plus m2 into g. So this is the simple problems in the mechanics. Okay, so easily we can solve this one. This is the basic Atwood machine. Next class we'll discuss Atwood machines in horizontal Atwood machine. Here we'll keep one block and here pulley. Okay, so what is that acceleration and what is that tension? We'll try to find. Okay, so this is our Newton laws of motion first part. Okay, so thank you.